Okay, Pure 4, January 22, unseen. I don't know what it was used for. I don't know why we have it. It's just nice that we have an extra paper.
Yeah.
Oh, okay, let's go.
Okay, question 1A. Find the first four terms of the binomial expansion in ascending powers of x, given the coefficient as a simplified fraction. Okay, so with 1A, let's first of all write this in index form. So we're actually having two lots of 9 minus 2x to the power of negative a half. Okay, now we know when we're dealing with fractional negative indices, we actually need to make sure that this is 1. How do I do that? I take out 9. If I take out a 9, I have 9 to the power of negative a half, lots of 1 minus 2 over 9 x to the power of negative a half. Okay, so in actual fact, I then get 2/3, 2 over 3, lots of 1 minus 2 over 9x to the power of negative a half. This is the most important thing. Okay, now I can use the formula. So, first of all, my 2 over 3 is going to come out. Okay, and I'm just going to focus on the formula. So you remember your x is this minus 2 over 9 as well. And then your n is minus a half. Now, it wants the first four terms up to and including x cubed. So we know the first one's 1 plus n and then x. Okay, plus n minus 1 over 2 factorial times x squared plus n minus 1, n minus 2, x cubed all over 3 factorial. Okay, so then when we do this, what we're going to have? 2 over 3, lots of 1. And then you're just going to use a calculator, okay? Plus 1 over 9x plus 1 over 54 x squared plus 5 over 1458 x cubed plus ... Okay, now the most important thing now is to remember to multiply by 2 over 3. So then the approximation is going to equal 2 over 3 plus 2 over 27 lots of x plus 1 over 81 lots of x squared plus 5 over 2187 x cubed plus ... Okay, beautiful. That was really nice, 5 marks. And then it says by substituting x equals 1 into the equation to part A, find an approximation for root 7. So technically, what I'm now going to do in part B is I know that 2 over the square root of 9 minus 2x equals roughly, I think it's this one, yeah, equals this roughly. So now, if I want to find a solution to root 7, and they're saying use x equals what? So what do I have? I have 2 over the square root of 9 minus 2, which is 7. So I have 2 over root 7 is approximately 2 over 3 plus 2 over 27 lots of 1 plus 1 over 81 lots of 1 squared plus 5 over 2187 lots of 1 cubed. Okay, so I now have 2 over root 7 equals 1652 over 2187. However, I don't want 2 over root 7, I want root 7. So if I think about 2 over root 7, I know I can rationalise the denominator. If I multiply both by root 7, I'm going to have 2 root 7 over 7. Okay, again, I have not changed this. Even though I've multiplied this by root 7 over root 7, this is technically still 1. 2 over root 7 is the same as 2 root 7 over 7. They're exactly equivalent. So this equals 1652 over 218 using the approximation and substituting x equals 1. So how do I find root 7? Well, clearly I have to multiply both sides by 7, so I'll get rid of that, and then divide by 2. Okay? So, in actual fact, root 7 is approximately 1652 over 2187 multiplied by 7 over 2. How many decimal places did it want? 4. Okay, so that means when I put that into my calculator, 1652 over 2187 times 7 over 2, I'm going to get 2.643804, etc. 2.6438. Okay, this is to 4dp. Now, also, if I just type in root 7 into my calculator, just out of curiosity, I get 2.6457, etc. So you know that, it is an approximation, but we're nearly there. Brilliant. Well done. Okay, question 2. The curve C has parametric equations. Write down x over y in terms of t, given your answer in its simplest form. Okay, so x divided by y, and it's 1 mark, so this shouldn't take too long. T to the power of 4 over 2t plus 1 divided by y, which is the same as multiplying by the reciprocal, which is lovely because actually what we see straight away is a 2t plus 1 is a factor of both, and then t over 4 times t cubed, okay, is actually just t. Beautiful. Okay, part B, hence show that all points on C satisfy this equation, okay? Because what they're pretty much saying is we need to substitute these into each other so that we are going to have to use x over y. What do we know that x over y is? We know that's t. Okay, so I just need to substitute x over y into any one, either the x or the y equation. Both of them will give us the same answer because the curve C has these parametric equations. So because there's an x here, I'm just going to go with this left-hand side. But if you did the right-hand side, you should get the same one. So x equals t to the power of 4. We know that t is technically x over y to the power of 4 divided by 2 lots of x over y plus 1. Now, it's very important, if you've written it this way like I have, make sure you get these brackets here. So I'm going to have x equals x to the power of 4 over y to the power of 4 divided by 2x over y. Now, technically, if I wanted to add 1, what do I know? That they have to have the same denominator. So this becomes y over y, which then we know we could write it as 2x plus y over y. Okay, now we're going to have x equals x to the 4 over y to the 4 multiplied by y over 2x plus y. So x equals x to the power of 4y over 2x y to the 4 plus y to the power of 5. I'm going to multiply up on the left-hand side. 2x y to the 4 plus y to the 5 equals x to the power of 4y. So I'm going to get 2x squared y4 plus y5 times x equals x4 multiplied by y. Now, what do we want? We want y4. Okay, we have a y5. So you can see here that I've actually divided everything through by x and y. So I can divide everything by x and y. Or like factor it out essentially if I move it all. So I'm going to get 2x squared y4 plus y to the power of 5 of x minus x to the power of 4 of y equals 0. Now if I factorise out an x and a y, I'm going to get 2y cubed. No, 2xy cubed plus y to the power of 4 minus x cubed equals 0. So that means xy equals 0, or it means that this equals 0. So we have 2x y cubed plus y to the 4 minus x cubed equals 0. And we wanted a positive x cubed up here, didn't we? Yeah, so I can move everything to the other side. So therefore, x cubed minus 2xy cubed minus y to the power of 4 equals 0. Therefore proved. Beautiful. Nice and easy again. Now, if you do get to this stage, remember, if we have divided by xy, that means that xy equals 0. Okay, so it is good to factorize this out so we know what's happening here. Okay, we can't just go from here and then divide everything by xy. Technically, they factored it out and they've said that this multiplied by this equals 0, which is true. Okay, question 3. The curve C has equation. Find dy by dx in its simplest form. Okay, this is lovely then, isn't it? Okay, 3y squared. So we know this is implicit differentiation. So what we're going to have, bring the power down, 6y, and then because we've differentiated with a y, what are we going to put? Absolutely, dy by dx. Next up, minus 11 squared. We know that this is 22x. Sorry, not 11 squared, minus 11x squared. Here we're going to have a product rule. So v du plus u dv. So we're going to have plus 11x dy by dx, because that's a differential of y, plus u, which is y, 11, which is 11y. Then we have equals 20 dy by dx minus 36x plus 28. Nope, that's wrong. 36, sorry, and the 28 goes. I ended up copying down the question. So now I need to rearrange this. So I'm going to have dy by dx equals, we have our 6y, 11x minus 20. So I'm literally going to write this all down and factorize it. Plus 11x minus 20. And this equals, and I'm going to move everything to the other side. So I'm actually going to have 22x minus 11y minus 36. Okay, so that means that dy by dx equals 22x minus 11y minus 36 all over 6y plus 11x minus 20. Okay, and that's actually a really lovely question for 5 marks. Just make sure that you are double checking everything, your expansion. You know, sometimes you go a bit fast, can't you? So then, it then says the point 4k, where k is constant, lies on c. Given that k is less than 0, find the value of the gradient of c at p. So first of all, I need to substitute in 4 into my original equation to find k. So if I do this, I'm going to have 3y squared minus 11 times 16. Well, it's 11 lots of 4 squared, isn't it? Plus 11 lots of 4 lots of y equals 20y minus 36 lots of 4 plus 28. So what we're going to have, y squared, is going to be 3y squared. Okay, we're going to have 44y minus 20y. So here, I'm just going to move everything onto this left-hand side, which is going to give me 24y. And then now, I'm going to have 171, negative 171, oh my god, plus 144 minus 28. Okay, that's going to give me minus 60. Okay, when this equals 0, I have y equals negative 10 and y equals 2. I just put that into my calculator quickly. Alternatively, if you want, you could just divide everything by 3 and then factorize. Right, it does say that k is less than 0. Okay, so we're not going to worry about this. K equals minus 10. So now that k equals minus 10 and p equals 4, oh my god, this is so easy. We're literally just going to substitute this into the gradient function. So remember, x equals 4 and y equals minus 10. Let's substitute this all in because it wants the gradient at that point. Minus 20, I'm going to put this all into my calculator. This equals minus 9 over 2. Wow, what a beautiful question. 10 marks. That was very nice. Okay then, question 4. Okay, so nice and easy. We need to split the first one into partial fractions. So we know if we have 4 over x brackets x minus 2 all squared. Remember, we're going to have a over x plus b over x minus 2, and then lastly plus c over x minus 2 all squared. So now we're going to have a lots of x minus 2 all squared plus b lots of x minus 2 plus c lots of x. So 4 minus 4x equals this. Okay, so when x equals 2, we're going to have 4 minus a is minus 4 equals 2c. So therefore c equals negative 2. When x equals 0, I'm going to have 4 equals 4a. So a equals 1. And then with b, what we're going to do is equate coefficients. So if I think bx, when I multiply this, I'm either going to have bx squared or minus 2bx. And on this side, if I wanted to, I know that ax squared plus bx squared must equal 0x squared. So we can do that. So ax squared plus bx squared is going to equal 0x squared. So obviously, if I have 1 plus b equals 0, b must equal negative 1. So expressing this in partial fractions, we're going to have a is 1, so 1 over x, b is minus 1, so minus 1 over x minus 2, and c is minus 2, so it's minus 2 over x minus 2 all squared. Okay, so now we've split this into partial fractions. Question B says, hence find the integral. Okay, so if I'm going to find the integral, if I'm going to integrate all of this. Okay, a few things to watch out for here. So, integrate this with respect to x. Now, we know, integrate 1 over x, what do I get? Ln of x. Okay, minus ln of x minus 2 divided by the differential of the bracket, which is 1, so that's fine. Then, I see a lot of people here, they get into this lns, and then they start learning this. Okay, remember, this is a square, this is different. We're only learning this because when we bring this up top, we're going to get the power here, minus 1. This is 2 lots of x minus 2 squared to the x minus 2 to the power of minus 2. So increase the power by 1, we get to minus 1. Okay, divide by the new power. Remember, this is a negative 2 here, it's now going to become positive 2. So this is actually plus 2 over x minus 2, and then remember, plus c. Okay, so there is the integral, nice and simple. It now wants us to find the integral. Brilliant. I mean, could we simplify this a little? We could. We could have ln of x over x minus 2 plus 2 over x minus 2 plus c, simplified form. However, in the mark scheme, yep, it's okay. Brilliant. Then, part C, we need to integrate between 5 and 3, and it wants it to be rational. So I'm going to do the same, but this time between 5 and 3. So if you think I'm going to have ln of 5 over 5 minus 2, which is 5 over 3, plus 2 over 5 minus 2 is 3, minus ln of, and now I'm going to substitute 3 in, 3 over 3 minus 2 is 3, plus 2 over 3 minus 2 is 2. So this means I'm going to have ln of 5 over 3 divided by 3 plus 2 over 3 minus 2. This is going to simplify to ln of 5/9 minus 4 over 3. Nice and simple. That was a very lovely question, actually. Question 4.
Okay, question 5, vectors. With respect to a fixed origin, the lines L1 and L2 are given by the equations, where lambda and mu are the scalar parameters. Show that L1 and L2 meet and find their position vector of their point of intersection A. Okay, so if we need to show that they meet, essentially we need to set up a pair of simultaneous equations and find where they meet. So we know that 4 plus 2 lambda, because I'm going across here, and 4 minus 3 lambda, and minus 5 plus 6 lambda, this is going to be equal to 13 plus 5 mu, minus 1 plus mu, and 4 minus 3 mu. Okay, so we can set up some simultaneous equations. I'm going to rearrange the second one, because this looks the easiest, by adding 1 to both sides. So I'm going to have 5 minus 3 lambda equals mu. Now I can substitute that into the first or the second one, it really doesn't matter. They do intersect, so we know that we're going to have the same values. So we're going to have 4 plus 2 lambda equals 13 plus 5 lots of 5 minus 3 lambda. So 4 plus 2 lambda equals 13 plus 25 minus 15 lambda. So 17 lambda equals 13 plus 25 minus 4 equals 34. So lambda equals 2. If lambda equals 2, I have 5 minus 3 lots of 2 equals mu. So then 5 minus 6, so mu equals minus 1. Now the final check is to check that it works in the last one. Okay, so we're going to have minus 5 plus 6 lots of 2, which we know is minus 5 plus 12, equals 4 minus 3 lots of minus 1. Okay, which is 4 plus 3, minus 5 plus 12 is 7, 7 equals 7, therefore lambda equals 2, mu equals minus 1. Okay, that part's perfect. So show that they meet, okay, so therefore they meet because lambda and mu are the same for all of them. And then find the position point. So you can use either rule and substitute in. So if I substitute in the value of 2 into here, I'm going to have 4 plus 2 lots of 2 is 4, which is 8. 4 plus 2 times minus 3 is minus 6, minus 2. Minus 5 times, no, sorry, minus 5 plus 2 times 6 is 12, is 7. So I get 8 minus 2, 7. Now, if you wanted to, we could do the same on this side. So 13 plus minus 1 lots of 5, minus 5. Minus 1, oh sorry, this is 8. Minus 1, minus 1, minus 2, 4, minus 3, it's plus 3, it's 7. So we can see we get the same point. And it says find the position, the point A. Okay, that's fine. 8 minus 2, 7. Beautifully done. Now it says find the acute angle between L1 and L2, given your answer in degrees to 1 decimal place. So, because they're both from a fixed origin, this is perfect, we're just going to do the directional vectors. So we know cos of the angle A equals direction vector, the dot product of both direction vectors of each line, divided by the magnitude of each direction vector. So, okay, so we're going to have 2 minus 3, 6, 5, 1, minus 3. Okay, so the dot product is 2 times 5, 10, minus 1 times 3, minus 3, 6 times minus 3, minus 18, over. Now the magnitude This becomes minus 11 when you erase it. Okay, 2 squared plus 3 squared plus 6 squared, square rooted. Now, it doesn't matter here about the negatives because technically, well, not technically, we are squaring each one. Okay, so the negatives will, we know that a negative squared is a positive. We're going to have 4 plus 9 plus 36, and if you're putting this into your calculator and you're not getting root 49, I can imagine it's because you've done 2 squared minus 3 squared plus 6 squared, okay? Your calculator, if you don't put brackets here, will take that as minus 9. Please be careful. We should all know this now, though. You've had a calculator long enough. So 25 plus 1 plus 9, and then we're going to get root 35, okay? So then we're going to have shift cos. Now remember, we want it in degrees to 1 decimal place. So shift cos minus 11 over root 49 times root 35. This is going to give me 105.4 degrees. Okay, so say anything. It wants the acute angle. Okay, if it wants the acute angle, what do we know? It's between 0 and 90. So 180 minus 105.4 degrees is actually going to give me 74.6 degrees. Perfect. A circle with centre A and radius 35 cuts the line L1 at the points P and Q. What is P and Q though? Okay, so there's a circle. Okay, so let's do some drawing first before. Okay, so we have a circle, centre, A, which we worked out. This is 8 minus 2, 7. Now, what do we know A? What do we know about A? A is where L1 and L2 meet. It's where they intersect, okay? So let's just draw 2 random lines. Okay. So we could say that this is L1. We could say that this is L2. Actually, should we do this in a different colour? Yeah? Okay. Let's call this one L1. Let's call this one L2. It may not be drawn to scale. Right, then. Centre A and a radius 35. A radius of 35. Okay. So for radius, R equals 35. And L1 cuts the points at P and Q. Find the coordinates of P and find the coordinates of Q. Given the x-coordinate of P is greater than the x-coordinate of Q. Okay, and then P is greater than Q. Okay, so if it has a radius of 35, what does that tell me? It means the magnitude is 35.
From here to here.
Yeah, so the magnitude's 35.
Yeah. So what they're trying to do here, Miss.
So if the magnitude's 35 though,
hypothetically say that to P here.
okay, so we know that P and Q, regardless of what they are, we know that their vector is in fact 4 plus 2 lambda, 4 minus 3 lambda, minus 5 plus 6 lambda. Okay, and if we know that the radius, the length, is 35, technically, that means, so the point Q to the point 8. So we're going to get 4 plus 2 lambda minus 8 squared plus 4 minus 3 lambda minus 2 squared, and then minus 5 plus 6 lambda minus 7 squared. This is going to equal 35 squared. Is that right?
Yeah.
So now, using this, we can expand out all the brackets. Well, let's just sort this out. So we're going to get 2 lambda minus 4 squared plus 6 minus 3 lambda squared plus 6 lambda minus 12 squared equals 1225. So now we can expand and simplify everything. Okay? And this is because it's the same. You know, like if you had 2 points, 2 coordinates, don't you? So let's say this is 4, 2. 10 minus 3? No, 10, 3. How would we find the equation of this line? It's like Pythagoras. Yeah? So we're going to do 10 minus 4 squared plus 3 minus 2 squared. That's what we're doing here, isn't it?
You don't have to do that.
That's what we're doing here.
If you just
However, instead of writing like x, y, z, because we don't know the points, we know that the point will be this. Okay? So we're going to have 4 lambda squared minus 4 times 4 times 2 minus 8 minus 16 lambda, yeah? Plus 16.
yeah.
Okay. Plus 9 lambda squared minus 3 times 6
You sure? Isn't 16 times 2?
minus 36 lambda
Isn't it 8?
plus 36. So this is 36 here. And then we have plus 36 lambda squared minus 12 times 6 times 2. Yeah. Minus 144 lambda plus 144 equals 1225. So we're going to have minus 36 plus 4 plus 9. So minus 23 lambda. And then we're going to have minus 16. Why do I keep forgetting these sixes? Minus 16, minus 36, minus 144. Minus 196 lambda. Right, 16 plus 36 plus 144. And then I'm going to minus 1,225 from the other side. Minus 1029 equals 0. So I'm going to divide everything by negative 23. I hope it's a factor. Divided by 23. Nope, it's not a factor. Oh, does this mean I'm going to get awful numbers? Okay, scrap that. I'm not going to divide by 23. I'm going to put this straight into the calculator, okay? Okay, I've just realised where I've gone wrong. This is, in fact, 4. I don't know why I got a negative. 4 plus 9 plus 36. There seems to be so many 6. Okay, this is 49. Okay, now let's try this. Second. So now, okay, I'm going to factorise this. So before, I'm going to divide everything by 49. This becomes minus 21. And then minus 4 lambda. 7 and 3. So we're going to have lambda minus 7, lambda plus 3. Is that right? Yes. Okay, so lambda equals 7, lambda equals negative 3.
And you get the 2 points.
Okay, so now I'm going to have to put in 7 and minus 3 to get my 2 points. So what we're going to have, if I put in minus 3, 4 minus 6, minus 2, 4, what am I putting in? Minus 3 and 7. Plus 9. 9 times 3.
No, I was doing that one as well. That's fine.
Oh, so that's 9,
Yeah, that's right. That's right.
13,
Thank you, sir.
18, minus 5, minus 18. No worries, thank you. Minus 5, minus 18. This is minus 23. Okay, now let's do 7. 4 minus 3 times 7, minus 17. And then minus 5 plus 6 times 7. Oops. Minus 5 plus 6 times 7 equals 37. Did you check my math on this? Oh, because my calculator's let me down before. Right, just check it. Right, everyone just check I've done this right, because my fingers must be wider today. Okay, minus 2, check. 4 times minus 3 times minus 3. No, 4 plus 13, yeah. Minus 5 plus 6 times minus 3. Oh my god. Minus 5 times 6 plus 6 times minus 3. Minus 23, okay. And then what we're going to have, 18 minus 17, 37. I think this is all right now. 4 plus 2 times 7. Yeah. 4 minus 3 times 7. Check. Minus 5 plus 6 times 7. For some reason, every time I go to click something, it says answer. Okay, 37. Okay, this is brilliant. Right, sorry. It says that the x-coordinate of P is 8 than the x-coordinate of Q. So this is P. So P equals 18 minus 17, 37, and Q equals minus 2, 13, minus 23. Okay? That's beautifully done. That wasn't actually too bad a question. However, you can see I've had to use colour coding here. I think the hardest part of this question was using my calculator and counting properly. Well done. So, use integration by parts to show that. Now, automatically, I see an e to the x and a cos, okay? I'm going to get a loop, right? Because we know that sine cos minus sine cos, they keep integrating differentiation, and e to the x and e to the x is the same, right? We're just going to get a loop. So just be prepared for the loop. Are we ready? So, the integral of e to x cos 3x with respect to x. So step 1, integration by parts. Doesn't matter which way. Okay? So, if I wanted to, I could put e to the 2x here, and I could put cos to the 3x here. Did you do it this way? Brilliant. So if we differentiate e to the 2x, what do we get? 2e to the 2x. If I integrate cos to the 3x, I get sine 3x divided by 3. Okay, if you're not used to this method, this is my magic number 7, have a look at the actual integration video I made. Okay, so let's have a look. So we're going to have, so this equals, so e to the 2x over 3 sine 3x minus the integral of 2 over 3 e to the 2x sine 3x with respect to x. Okay, now in these types of questions, to make everyone's life easier, I'm going to take out the 2 over 3. So this now becomes here. Okay? Right, so now I'm going to have equals e to the 2x over 3 sine 3x minus 2/3 lots of. Now we know here we have another product, so we're going to have to do the integration by parts again. So if I do this, I'm going to put my e to the 2x here, sine 3x here. So I'm going to get 2e to the 2x. Sine is minus cos 3x over 3. So now I'm going to get magic number 7 minus e to the 2x over 3 cos 3x minus the integral of negative 2 over 3 e to the 2x cos 3x with respect to x, okay? Now you think to yourself, oh my God, this is going to go on forever, and it is going to go on forever, okay? This is great. You've done it twice. What do we notice? You should notice straight away that e to the 2x cos 3x is our original one, okay? So what we're going to do is we're going to tidy all of this up. So what do we know? We have the integral of e to the x cos 3x with respect to x equals e to the 2x over 3 sine 3x. Okay? Now if you think about it, let's expand this bracket here. Let's get plus 2 over 9 e to the 2x cos 3x, right? Now, earlier, you know, when I took out the 2 over 3, I'm going to take this out again. So now this becomes plus 2 over 3. But now I'm multiplying it by this negative, right? So now this becomes negative 4 over 9, lots of the integral of e to the 2x cos 3x with respect to x. So this is where I am. Yeah? Now, do you know what I'm going to say to myself? Well, actually, imagine if you had this. Imagine if you had x equals 4 plus 2y minus 4 over 9x. What would you do? If you want... Yeah, you're going to put the x's on one side. This is technically what we have here. Imagine this was our x. So I'm going to add 4 over 9 to both sides. Oh, for some reason it won't let me colour this up, but you know what? I'm going to just put it in white. Okay? So if I add 4 over 9, lots of that to both sides, what am I technically going to get? What's a whole 1 plus 4 over 9? Okay, 13 over 9. So I'm going to get 13 over 9, lots of the integral, e to the x cos of 3x with respect to x, equals e to the 2x over 3 sine 3x plus 2 over 9 e to the 2x cos 3x. Great. So how do I find the integral on its own? Yeah, I'm going to divide both sides by 13 over 9. So the integral of e to the x cos 3x with respect to x equals, what happens when I divide by 13 over 9? So 3 over 13 e to the 2x sine 3x plus 2 over 13 e to the 2x cos 3x. Is that right? Plus c. Let's just check that we haven't made any silly mistakes. So 6 marks, and actually that's pretty simple. You just have to remember this part, yeah? Perfect. Okay, question 7. Water is flowing into a large container and is leaking from a hole at the base of the container. At time t seconds after the water starts to flow, the volume of water in the container is modelled by the differential equation. Solve the differential equation to show this. Okay, so with this, dv dt equals 300 minus kv. So differential equations, we have to put them both over. So I'm going to have 1 over 300 minus kv dv equals dt. Okay, and technically this is 1 dt, right? So now if I integrate both sides, I'm going to get ln of 300 minus 3k, sorry, I don't know where that 3 came from, kv, and what do we do? Divide by the differential of the bracket. Plus, equals, what's 1 integrated? T plus C. Okay, so I can multiply both sides by negative k now. So I get ln of 300 minus kV equals minus kt plus c. Now, this, because k is a constant anyway, it doesn't matter. I know you might be thinking, well, we should have minus kc. It doesn't matter. C is now changed. C was c, now it's multiplied by minus k. It doesn't matter, it's just a constant. We don't even know what it is yet. So now, how do I get rid of a ln? E. So if I e both sides, I get 300 minus kV equals e to the minus kt plus plus c, because I've e'd both sides, right? Now, what do we know about e to the a plus b? It's the same as e to the a times e to the b. Okay, so we're going to let e to the c. Now, in the question, did they tell us a? Yeah, let e to the c equal a. So then we can literally say 300 minus kV equals a e to the minus kt. What does it want? V. Yeah. So now, what do I do? Take away 300 from both sides. So minus kV equals minus 300 plus ae to the minus kt. Divide both sides by negative k. I'm going to have v equals positive 300 over k minus a over k e to the minus kt. Now, does minus a over k, can I just leave it as a? It's just a constant. Like, we still don't know what this constant is. This constant just keeps changing, though.
That's how I struggled. I didn't know what to do with it.
Yeah, we just leave it. We just keep leaving it. Like, the constant can keep changing. You don't have to find the constant yet. No. Okay, so next up it says, hence find, according to the model, the time taken for the volume... Oh, no, sorry, I'm lying. Given that the container is initially empty, okay, and that when T equals 10, the volume of the water is increasing at a rate of 200. What does that mean? Yes, dV dt. Okay, the rate equals 200 when T equals 0. So let's differentiate this then. So if I'm to differentiate this, 300 over k differentiated, what is it? 300 over k is just a number. What happens if we differentiate a number? It's nothing, exactly. ae to the minus kt. We're going to have ae to the minus kt multiplied by the differential of the bracket, which is minus k. Now, remember, minus k times a, what do we know? It's just all constants, okay? So, God, that's really pixelated on the screen, isn't it? So, we're going to have 200 equals... Okay, so, we have now like two unknown variables. So what we need to do in this case is go back to the question. And let's just double check something, because this isn't right. We can't just now say that minus k times a is something. Given that the container is initially empty when t... okay, so when t equals 0, v equals 0. Okay, so we're able to do this now. When t equals 0, v equals 0. So we're going to have 0 equals 300 over k plus a. Because e to the power of negative 0 is 1. Okay? Yes, that's perfect. Okay, so what does a equal? Minus 300 over k. Yeah? Okay, so this makes more sense. So now I'm going to have 200 equals a times e to the minus kt times minus k. Wow, there's so many minus k's. Right, lucky for us, these k's are going to cancel. The negative is going to become positive. So I get 200 over 300 equals e to the minus k. And what was our t? 10. So 2 over 3 equals e to the minus 10k. How do I get rid of an e? Ln of 2 over 3 equals minus 10k. Minus 1 over 10 ln 2 over 3 equals k. What did it actually want? Find the exact value of k. Perfect. Minus 1 over 10 ln 2 over 3. Yeah, just to make this clear, this is dy by dx here. And then that was just v. That was from the initial information, okay? Brilliant. So then it says hence find. So now we know that v equals 300 over k plus, and what was our a? Nope. Minus 300, wasn't it? So what is it? 300 over minus 1 over 10 ln of 2 over 3. Oh my god. Plus minus 300 over k. Minus 1. Alright, do you know, I'm not going to write this all out again. Let's just leave it whatever it was. I can't even rub it out now. Right, okay, so right. Hence, find, according to the model, the time taken for the volume of the water to reach 6 litres. Now, something we need to just double check is the units, is centimetres cubed. What do we know about centimetres cubed and litres? 1 centimetre cubed, 1,000 centimetres cubed equals 1 litre. Okay, so 6 litres is 6,000. Hence, find, according to the model, the time taken for the volume of the water in the container to reach 6,000. So now we're going to have 6,000 equals. Wow. So we need to find the t, right? So we're going to have 6,000 equals. I'm going to have to write this whole thing out. Right, let's do some simplifying in our lives. What was k again? Minus 1 over 10 ln 2 over 3, and a was negative 300 over k, right? So 6,000 equals 300 times negative 1 over 10 minus 3,000 over ln 2 over 3. Yeah?
Why is it 3,000?
Because 300 divided by minus 1 over 10 is going to give me negative 3,000. Yeah? Plus minus 300 over k, oh, it's the same again, ln 2 over 3, e, oh my god, to the plus 1 over 10, ln 2 over 3 multiplied by t. Brilliant. It wants it to the nearest second, so actually we can use a calculator and help us out. Okay, so in my calculator, I'm going to add this to both sides and divide both sides by this. Okay? Okay. Again, negative.
Yeah, miss, I think it's because you did minus 3,000 the second time, but it should be positive because a is negative and then k is also negative. So negative divided by negative.
So this should be a positive?
Yeah.
Okay, brilliant. So 0.1890697 equals e to the power of t over 10 ln 2 over 4. Okay, so now if I ln both sides, ln of my answer equals t over 10 ln 2 over 3. So what I'm going to do, multiply both sides by 10 and then divide by ln 2 over 3. Okay, so ln of answer equals times 10 divide by ln 2 over 3. So I now get t equals 41.0797. To the nearest second, t equals 41 seconds. Okay, to be honest, once you've written this, the last part, apart from this learning it, was just putting it all into the calculator. Just checking that you've put all the numbers in correctly and the signs, etc. And that's it. Full 2 marks for that. Okay, use proof by contradiction to prove that for all positive real numbers x and y. Okay, so step 1. If we're going to contradict it, we need to assume, okay, so therefore assume for all positive real numbers x and y, that 9x over y plus y over x is less than 6. Now, something that we have to watch out for here is some people put less than or equal to 6. Okay, that's not the opposite of greater than or equal to. So remember when we're dealing with inequalities, some people want to... So remember we're dealing with inequalities, if we want to multiply, you know, like if we had... for example, minus a is less than 4. That means a is greater than 4. Why? Because if we multiply or divide by negative, we have to change the sign, right? So we have to be really careful here. We have to make sure that we multiply or divide anything by positives. Okay? So it's better if we know that we have whole numbers. So we can add the fractions, we can cross multiply to add the fractions if that's where you're going with this. Like you can do a few different methods to start. So if we cross multiply, what do we get? We get 9x squared plus y squared over xy is less than 6. Okay, so once we do this, we now have to, if we cross multiply, do we know that x and y are positive or not? Okay, so because we're saying that x and y are positive real numbers, we can multiply both sides by x and y. So x squared plus y squared is less than 6xy. Move everything to the other side. 9x squared minus 6sy plus 6xy plus y squared is less than 0. Now, can I factorize 9 minus x squared minus 6xy plus y squared? Which is going to give me 3x minus y, 3x minus y, which is less than 0. Now, if you're not sure how to factorize this, you can use your calculator. Just use your a equals 9, b equals negative 6, and c equals 1. Okay, in this case. And then you'll have 3x minus 1. So we're going to have 3x minus y all squared is less than 0. Now, what do you know about square numbers? Yeah. Okay. N squared is always greater than or equal to 0. Okay? Now, with the sentence writing here, it's quite crucial that we get this last part correct. Okay? This contradicts original statement. Okay? Therefore, 9x over y plus y over x must be greater than or equal to 6. Okay? And if you really wanted to, you could put here all square numbers are equal to 0 or positive. I know that does say this is what that statement means, okay? But if you wanted to, this is going to get you the full 4 marks here. Okay, question 9. So, Figure 1 shows a sketch of a closed curve with parametric equations. The region enclosed by the curve is rotated through pi radians about the x-axis to form solid revolution. Okay, if we're looking at a solid and we know it's been rotated through, what do we know? That this is actually, we're going to need to have the integral multiplied by pi of y all squared. Okay, it's going to be our volume. Now, because we have parametric equations, we're going to have to sort some stuff out, aren't we? So, let's have a look, shall we? Show that the volume of the solid of revolution is given by this. Okay. So we need to have this in terms of d theta. So far we have it in terms of dx, right? So how are we going to get d theta? So first of all, if we know that x is 5 cos of theta, if we differentiate x with respect to theta sine cos minus cos, we're going to have 5, negative 5 sine theta. So that means that dx equals minus 5 sine theta d theta. Okay, so now when I do my integral, I'm going to have the integral of pi of y squared. So y squared is 3 sine theta minus sine 2 theta squared. And then instead of writing dx, we're going to multiply by minus 5 sine theta d theta. Okay, so now we've got to expand, simplify. So I just want to show you, though, that they've taken out the 5. Okay, so we can take out the 5 but leave in the negative. So let's do this. Oops. Okay. So I'm going to take this 5 out, just because I know I'm going to need to take 5 out. Yeah, because it wants us to show in a specific format. So I'm going to get 5 pi integral. I'm not going to worry about my a and b yet. Okay, 3 sine minus sine 2 theta all squared. Remember, this is 3 sine theta minus sine 2 theta multiplied by 3 sine theta minus sine 2 theta. Okay, people always forget about this, but it's really important. So we're going to have 9 sine squared theta minus 3 sine theta sine 2 theta. Okay? Minus 3 again of that. So what does that make this? 6. Minus 3, minus 3. Then we're going to have plus sine squared 2 theta. Okay, what is all of this multiplied by? Negative sine theta d theta. Okay? So now we're going to have 5 pi integral. If I multiply everything by negative sine theta d theta, minus 9 sine cubed theta, plus 6 sine squared theta sine 2 theta, minus sine cubed 2 theta. Okay? Minus sine squared 2 theta sine theta. Oof, nearly made a mistake then. D theta. Okay. It is, isn't it? Right, what have they taken out though? They've taken out sine cubed theta and we've got causes, but what do we know about sine 2 theta?
2 sine theta cos theta.
Yeah, 2 sine theta cos theta. So we know that sine 2 theta is actually 2 sine theta cos theta. So I'm going to replace that everywhere I see. Right, so what's sine squared 2 theta then? 4 sine squared theta cos squared theta. Yeah. Let's watch out for that one. Okay, so we're going to get 5 pi integral minus 9 sine cubed theta plus 6 times 2, 12. Sine squared theta, so I'm going to get sine cubed theta cos theta. Then minus 4 sine squared sine cubed theta cos squared theta d theta. Okay. Now I look back at this, and it says I've got 3 minus 2 cos theta squared, then all multiplied by sine. Okay, so let's take out sine cubed because they all have that. 5 pi, lots of, sine cubed theta. What am I left with? I'm left with minus, I'm going to write it slightly different though. Minus 4 cos squared theta plus 12 cos theta minus 9. Okay, so that's how they factorise that. Okay, minus 4, 12, and minus 9. So then you can just literally write 5 pi lots of sine cubed theta 3 minus 2 cos theta squared, because technically what we have here is difference of, no, we don't have difference of 2 squares, we just have a nice easy quadratic. Okay, therefore proved. Okay, 4 marks, took me 6 minutes. It wasn't very nice really, was it? But we did show it. Okay, now we need to find alpha and beta, right? So what do we know about alpha and beta? We know it's when, what? It's when y equals 0. Yeah? It's when y equals 0. So technically, that means 3 sine theta equals sine 2 theta. Okay?
Because like it's y equals 3 sine theta.
Yeah, because when y equals, I've just put y equals 0 and then move this to this side. Yeah? Now, what does that mean? Okay, what is sine 2 theta? Equals 2 sine theta cos theta. So actually I can divide everything through by 0, right? By sine theta. Yeah, okay. So then I get cos theta equals 3 over 2. Yeah. Was that yeah? Not an So then what does theta equal? Oh, we're in radians, aren't we? 3 over 2 though.
I don't know. Don't trust this. This is just like.
Yeah, that's 1.5. That's not going to work. Maybe we can't divide through by sine. No. Alright, let's go back a minute. Let's stop. Everyone just calm down. Right, let's get to this part. Okay, 3 sine theta. I'm going to do this the other way. Minus 2 cos theta sine theta, yeah? Okay, I tell you what. They all have a sine theta in common. So sine theta, brackets, 3 minus 2 cos theta equals 0. So this is where sine theta equals 0. And 3 minus 2 cos theta equals 0. Okay, this is going to give me 3 over 2, isn't it?
Minus 3 over 2.
No, positive.
Oh yeah, my bad.
Yeah? I'm going to get cos theta equals 3 over 2. Well, sine of 0 is easy. What is sine of 0?
0.
And?
And pi.
And pi. Okay? Cos theta, we're just going to reject this. Perfect. So we just have between 0 and pi anyway. 0 and pi.
Why did you put pi?
Why did I put pi? Oh, we haven't finished yet, guys. Hold your horses. This is what y equals, right? Between 0 and pi. We need to find out what x equals. So x equals 5 cos 0. X equals 5 cos pi. Okay? So what is 5 cos 0? 5.
Yeah.
What is 5 cos pi? 0. Yeah.
Minus 5.
Minus 5.
Yeah.
Yep. That makes more sense. Okay, minus 5. Now, if you look at this, we have a positive, we have a negative, don't we? So this does make sense. So don't fall into this trap here, okay? This is a really common mistake here, because when you divide through by sine theta, we're technically saying that sine theta must have equaled something. You know, like sometimes when I say don't just divide through by x, especially when we have a cubic, this is why. And then also you need to remember to put these values in. I can't believe that's taken us 10.5 minutes.
It's an annoying question, actually.
Yep. We haven't even got through to the fun part yet. Okay, so for the second part, use substitution of u equals cos theta. Okay? So, we already know that we're integrating between 5 and minus 5, right? Remember, this is our x values, technically. Okay? We're now saying that u equals cos theta. So we're going to have sine cubed theta, brackets, 3 minus u squared d theta. That's currently what we have right now. Okay? Yeah, that 2 was just a bit lag there. Okay, it's currently what we have. So first of all, there's a few things we need to do. We need to change the limits. We need this in terms of du. Okay. Now what we're going to find is something really beautiful in a second. Okay? Do not try and change the sine cubed theta for a sec, and I'll show you why. So, first things first. If x equals 5 cos theta, that means x equals 5u. So what's u? X over 5. So what do we have to do? Divide these both by 5. Yeah, to find u.
Why is...
To find the limits of u. So we're going to get 1 minus 1. Yeah, so we've just had a conversation. Maybe alpha is 0 and beta is pi, that we leave that in part 4, but then we need to do that second part to get to 5 and minus 5 100%. Okay? Then, right, so what is d theta? So if we differentiate u with respect to theta, cos differentiates to negative sine. So now we're going to have this. Sine cubed theta equals, bracket 3 minus 2u squared. And then what is d theta? D theta is 1 over negative sine theta du. If I rearrange this. Okay, this is going to be lovely because this means that the sine's going to cancel and we're going to end up with a sine squared. Now, we like a sine squared. Why do we like a sine squared? Yeah, because sine squared equals cos squared minus 1. So now we're going to have the integral between 1 and minus 1 of... there's still a 5 pi here. Of, what is sine squared?
1 minus cos.
1 minus cos squared theta, 3 minus 2u cubed, negative, this is all negative, guys, with respect to u, because this negative doesn't go away. Sorry, guys, there should be a squared here. I don't know what happened. Just be careful that you're not writing down crazy numbers. So we're going to get 5 pi 1 minus 1. So then we're going to have, this is u squared minus 1. Okay, if I expand the brackets, and I know that, what do I know? If cos squared theta equals u, cos theta equals u, then cos squared theta equals u squared. Lots of 3 minus 2u all squared with respect to u. Okay, so now what do we have? We're going to have u squared minus 1, lots of 4u squared, minus 6u plus 9, right? So we're going to have 4u to the power of 4, minus 6u cubed, plus 9u squared, minus 4u squared, plus 6u minus 9. Okay, so now I get the integral between 1 and minus 1 of 5 pi 4u to the power of 4 minus 6u cubed plus 5u squared plus 6u minus 9. Perfect. With respect to u. Okay, so now we're going to integrate this, yeah? Wait, no? Sorry. This is 12. Okay.
Miss, what's the final answer? Like for the volume?
So, 12, 12. Okay, so just watch out for all these silly mistakes. Right, so now we're going to integrate. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1. Okay, so we're going to put it in between 1 and minus 1 and multiply the whole thing by 5 pi right at the end. Okay, so when I put in 1, this should be easy, right? I should just have 4 over 5 minus 3 plus, oops, what on earth has happened here? Plus 5 over 3 plus 6 minus 9. Minus. Now on this side, remember when you put in the negative 1, some of you may go wrong because of your calculator. Okay, it's going to give me minus 4 over 5 because negative 1 to the power of an odd is going to give me a negative, right? So then I'm going to have minus 3, minus 5 over 3, plus 6, plus 9. Then I'm going to multiply the whole thing by 5 pi, so let's see what happens.
Here it says that the 4u to the power 4 is negative. Yeah.
Okay, so I get a negative 1 here. Technically, what I've done is I've done the areas that I should have done between minus 1 and 1. It's fine though, because you can just take the positive and then multiply by 5, because we obviously can't have a negative volume. So then I'm going to have 196 pi over 3 units cubed. Okay, and this is the final volume. Okay, when it does come to areas, volumes, etc., if you do get the negative, that's fine. You can take the positive. Just make sure you've done it for the whole thing. So you might have done it slightly different. That's okay. Just make sure you get 196 pi over 3 units. Now, lots of people in my class have made really silly mistakes here. I've actually made 2 during this. Silly things like I accidentally put a cubed here instead of a 2. Earlier, multiplied out, got a number wrong. You know, there should have been 12, not 6. Just please watch out for all of that. Well done.